Problem 2 is about the normal approximation of binomial. According to a September 2008 Poland report done by Pew Internet, 62% of employed adults use the internet or email on their jobs. 2.1. Use the normal approximation to estimate the probability that more than 170 out of 250 employed adults use the internet or email on their jobs. 2.2. Estimate the probability that more than 2/3 of 250 employed adults use the internet or email on the jobs. Do you see the difference? The first problem is about counting more than 170 people. So we are talking about 171, 172, 173, and so on, all the way up to 250. The second problem is about the proportion. Explicitly, it gave you a proportion of 2/3. So we need two different formulae. One is for counting binomial sum, and the second is for proportion. Now, the second one will be far more important than the first one. The reason? Well, that will be answered someplace in chapter 9. However, we'll do the first one before the second one, partly because that's the way our textbook is written. So don't forget about the second problem, even though I'm doing the first problem before the second one. Okay, here we go. Normal approximation. You have to draw a picture, but here's a dilemma. What is the center? If you don't know what the center is, how in the world are you going to put 170? This 170 should go somewhere. Does it go here or there? Well, in order to answer this question, we need these formulae. Mu is NP, sigma is square root of NP1 minus P. Mu equals NP. Does it make sense? To me it does. P is the probability, 62%, and N is the total number. So what do we get? 62% of 250 people. That turns out to be 155. For example, if you roll a die 600 times, how many aces do you expect? 100, give or take. Why? Because it's 1/6 of 600. Exactly the same thing is going on. 62% of 250, that's how you get the center, 155. How about the denominator, standard deviation? Well, you'll have to just use the formula, square root of NP1 minus P. We end up with something like this. The derivation of this formula will be done in 3000 level math course, not here. Alright, we have the normal picture. Center and standard deviation, we are ready. Apply the z-score. End minus center over SD. End is 170, center is 155. Standard deviation, we calculated is 7.67 something. So here's the computation, and you get 1.95 approximately speaking. So in a normal table, you look at 1.95. Okay, in the second page, 1.9 is here, 1.95. Wasn't 1.94 or 1.95? 1.95, yeah, 0.9744. 0.9744 is the probability of this blue region we got from our normal table. A little bit more accurate computation using Mathematica yields this blue figure, 0.9746 something. Let's go back to the table. 0.9744, 0.9746, pretty close, but this is a little bit more accurate one. obtained by technology. So let's use this. So this is blue. In order to get the red, subtract from 1, and you get 0.025 something. We get about 2.53%. In summary, the center is the key. So how do you get that? Mu equals to NP. Standard deviation is sigma equals the square root of NP1 minus P. Using those, you can draw this normal picture. Center, end, 170, and z-score. End minus center over SD. Look up the table, get the probability, and we want the right-hand side, so subtract from 1. Now, do we have time to go over to an advanced solution? Let's do it. Advanced solution, I will accept the primitive solution we just talked about with full credit, but I think everybody should at least listen to advanced solution. So let's talk about it now. The advanced solution is based upon this observation. Bigger than 170 versus bigger than or equal to 171, they're the same because we are counting the number of people. There's no such thing as 170.7 people or something like that. It's either 170 or 171. But then again, if you go over to the normal picture, this is continuous random variable. So all those decimals are possible. How do we reconcile? Well, let's reconcile right in the middle. 170.5. So greater than 170, greater than or equal to 171, they're the same in terms of counting. For normal approximation, we take 170.5, right in the middle. Consequently, we get this picture here. Center is 155, end is not 170 anymore, 170.5. And then we are looking for this probability, visualize it by this red area here. Computation, well, pretty much the same. N minus center over SD. The difference is not 170 but 170.5. Calculate, we get 2.019 something, 2.02, not 1.95 anymore. So 2.02, not this one anymore. 2.02 is okay. 2.02, 0.9783. That's the probability. 0.9783 is probability for this blue. So the right is 1 minus of that. According to Mathematicas computation based upon 12 decimal digit, 0.97829, it's a little bit more accurate than the one we got from our normal table here. Pretty close, but this one is a little bit more accurate, so let's use this one. 1 minus of that, so we get that, and consequently we get this conclusion, about 2.17%, not 2.53%. It turns out this is better approximation than the one we did before. If you calculate the binomial probability using technology, you get 2.08%, so that's closer to this one than the one we had before. The one we had before was 2.5 something percent. If you hit 171, by the way, you're gonna get another answer which is acceptable in 1000 level, but not really desirable. The most desirable solution is the one we just saw, that advanced solution, 170.5. But if you use just 170, I'll accept it with full credit in 1000 level. That's because this is 1000 level. In higher level, of course, you have to do it in the right way. Okay, so much for 2.1, and let's go to 2.2. And be warned again, 2.2 is more important. This is more important. The reason why this is more important, this is more realistic, and this is connected directly to what we are going to do in chapter 9 and chapter 10. Okay. You have to draw a picture, but what's the center here? We are talking about the proportion, and the proportion given is 62%. That is going to be my center, 62%. Here's the formula, or formulae rather. Mu is p, the center is given proportion, and the standard deviation is square root of p 1 minus p over n. In this case, square root of 0.62 minus 1 minus of that over 250. 0.62 times 0.38 over 250, and then calculate the square root. Doing everything, we get this number. This number will go down to the denominator. Here's the normal picture. The center, 2/3 is over here. You see, we want more than 2/3. So this is 2/3. How do we calculate? Here we go. End minus center over SD. End is 2/3, center is 0.62, and SD we calculated right over here. Alright, run your calculator and you get 1.52 something. 1.52, let's go to our table. 1.52, where is it? Yes, right here. 0.9357. That is the probability of the left hand side, this part. So the right hand side is what we want, so we subtract from 1. Let's see, according to the Mathematicus computation, we get 0.935765. Is it pretty close to what we got in the table? 0.9357, 0.93576. Oh, they're pretty close. This is a little bit more accurate, so let's use it. 1 minus of that, 0.064 something. So what do we conclude? About 6.42% or 0.00642 is the desired probability. The probability that more than 2/3 of 250 selected people would use email or internet on their jobs. That concludes the exercise set for chapter 6.